There is Marcus going out, exiting stage right. Here's our next system coming in the Friday time frame. Do you think it's over with yet? No, because we get yet another system that comes in here into the weekend, literally deja vu all over again. It's just one after another. This is fascinating. Here's Marcus exiting. Here's our next system coming into the mid-Atlantic and then intensifying rapidly into a very deep system. Do you think it's over yet? No, watch this. Right across the Great Lakes, the next embryonic system forms and deepens very rapidly and comes up the East Coast. When's it going to end, guys? This is just one pattern after another that just continues to replay itself across New England.
Okay, so what about that? Well, here comes our next weather system, 10,003 millibar area of low pressure. This is a clipper system that's moved in, and what happens is it encounters just off the coast and spins up very quickly as a Miller B nor'easter. And so this would be valid Thursday night, Friday morning. There it is, 997. It very rapidly intensifies, throws back more moisture yet across Boston, though briefly. And then that system exit. Here, oh look, here comes the next one. Boom, 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 boom. 986, it looks like 964 millibars. That's pretty significant. Tight pressure gradient here. And so forth. And these systems are just amazing to watch over the course of the next 10 days. So what's going on, and why are we seeing these systems blow up? Okay, we have sea surface temperatures here that are above normal, and this is the current readings here. You can see the temperatures here, pretty warm across the tropics and subtropics to be expected. And then over here, up in the northern areas, a little upwelling is cooling off the temperatures, but these temperatures are well above normal. These are sea surface temperature anomalies, and notice we're at 4 to 5 degrees above normal here, just right off the coast of New England. This here is 10 degrees above normal. Pretty amazing stuff. So north of the Gulf Stream, or the head wall of the Gulf Stream, what you're looking at is sea surface temperatures that are well above normal for this time of year. Hence, any contrast in land, basically from the interior sections of northern New England, central New England, southern New England, northeast United States, wherever, contrasting with these warm sea surface temperatures is spinning up ferocious low pressure systems. Those low pressure systems and its counterclockwise movement is then throwing back more moisture into parts of New England. Here's a good example of that. We have the Alberta Clipper system that works in with some snow. We're talking about minimal amounts of snow for interior sections of New England, but watch what happens. Here comes the area of low pressure intensify, produces heavier snow across the Cape, moves on out, but the damage is done. The onslaught is continuing. And you can see the next weather system do the same thing, and so forth. So in terms of total snowfall, watch the snow build and watch where it builds. You can see eastern parts of New England, and the heavier snow's out to sea, of course, but the next system comes along, builds more snow, and look at Boston. Unbelievable. That's 10-day snowfall. And the other interesting thing we're starting to see here is pretty dangerous stuff. Roof collapse, a training facility on St. Mark's Street here. It looks like that's in the city of Worcester. No, it's Auburn in Worcester County, Massachusetts. Okay, in the vicinity of Boston from heavier snow. We also have a roof collapse at a mill on Center Avenue, and so forth. And we're seeing more and more of this starting to take place now. And you can see this is one system that's out. There's another one yet. And this is from Climate Nexus. You can see here the environment which all storms form is now different than it was just 30 or 40 years ago because of global warming. Over 90% of the added heat due to global warming has gone where? Into the oceans. On average, the air above the oceans is warmer by more than 1 degree Fahrenheit and more moisture by 5% since the 1970s from global warming. In the North Atlantic, there has been additional warming, and surface sea temperatures are over 2 degrees Fahrenheit. We just got to look at that. And this is above the 1981, 2012, 2010 average. Now, between January 26th, 28th, 2015, the sort of in the series of storms that were beginning to move into the region, the latest winter storm was in the right place, on the position to tap into the high moisture over the oceans and develop as it experienced a sharp contrast between the continent and relatively warm ocean. Whether warming causes more or less precipitation varies by region, of course. Exhibit A would be the west, but it changes the balance between snow and rain. As long as it stays below freezing, it'll be snow. The snow dumps are bigger. The snow season shrinks at both ends of winter. So more time is spent raining. Skiers in some regions benefit in midwinter, but with a shorter ski season. Well, right now we are seeing deep Arctic air preserve our local snows up here in Vermont. The snow is great. Conditions continue to support heavier snowfalls across the eastern coast of New England. Why? Above normal sea surface temperatures. Why is that? Climate change. There's your link. Roger Hill, Wuthering Heights Consulting.